Simon. I'm Shahin. So, this is our Battlebot. That is the name we came up for it at least. So the point of the Battlebot is to, as the name suggests, battle. Um, it uses randomized motion to travel across a surface and uses gears as a sort of grinder to eliminate any opponent or Battlebot in its direction or way. It also uses an optical sensor to stop any motion in front of it. Oh, yeah.
So this is our PowerPoint about our machine called the Vex Terminator.
Our original problem was too much time and materials, so we quickly decided on something that wasn't too complicated and shifted our focus on developing a warlike bot that would be able to move around and maybe.
What we are doing for it is we created a machine that could move forwards and backwards, turn left and right, and a little grinder that could be used as quote unquote threatening to anything or anyone who stands in the way.
Benefits to our solution. Our solution was great because it was entertaining and fun to play with. Our bot can sense things in front of it and then react and create a path to avoid the object/thing.
This is how we use the engineering design process. So first we defined the problem of the pesky battle bots. Then we did background research about the problem and materials we would need to solve it. We brainstormed the solution in the form of our original design and developed and tested the original design. After we realized how many materials it would take to make a Roomba, we redesigned to a BattleBot and tested the machine. After rigorous training, we communicated our results using this PowerPoint.
Our main obstacle was the amount of materials my design took up. We needed a bot that would take up less materials and be somewhat easier to build. Start over and try something new.
Reflecting, we worked effectively as a team. Liliane and Simon were doing the engineering. Shahin was doing me and Liliane. Shahin was doing coding and Charlie was doing the PowerPoint. We could have improved a lot. However, we accomplished multiple of them.
So this was our flowchart. So bunch of different paths for all the different parts of machinery that we used to make it. So here you can take a look at the this is what our mindset for the optical sensor, the bumper switch, and the motors.
This was our decision matrix. We ended up changing some of this info multiple times. So we each got evaluated based on if it were achievable with available resources, with limited time, and if the product actually met users' needs.
This is our original design. As you can see, the optical sensor is here, and the bumper switch right here. You could just take a look for it, but here was our original design, which we did end up changing.
This was our final code. As you can see, a lot of scrap parts were left due to trial and error and process of elimination. We at the bottom there's the major code for the actual movement of left to right because Vex VR doesn't offer a complete set of if a certain wheel if like the robots are turned left or right, because to its knowledge it's only controlling the wheels. So to make it turn left, you would have to make it so that the wheels would turn in a certain way, and I used functions to format that all together, and eventually made it into easier. Um,
Our final design, optical sensor, the chains, the motors, and the brain. Yep. Oh, and the weapon in the back, the grinding gears.
Uh, as we can see here is the wiring diagram. We changed this because of the. And as we can see here, the battery connects to both the optical sensor and the little button, their bumper switch, which turns off the machine, or turns on the machine and off. uh, we changed this again a lot, so this is no longer a thing.
Closing remarks. Throughout the project, our perspectives of computer science have changed. We have come to realize its importance in everyday life. In this project, we used the skills of problem solving, collaboration, communication, and creative thinking. This was great because we can use these skills later on in life, like in jobs and other stuff.
The end.
Thank you.
All right, let's give this thing a round of applause.